Good morning, guys. As a startup of physics, we are going to begin the first chapter of physics, the measurement and measuring instrument. In the introduction, they are talking about the measurement. Measurement is very important for our daily life and very basic for scientific studies. What is a measurement? Measurement is just assigning the numerical value to an event or an object in order to compare that event or object with other event or object. To make it simple, we can define the measurement as just determining the size or magnitude of a quantity. The next topic it is physical quantities and units. If we take physical quantities, it is classified into fundamental quantities and derived quantities. What is a fundamental quantity? The quantities which cannot be expressed by other physical quantities, they are called as fundamental quantities. For an example, we are having length, mass, time, temperature. The quantities which can be expressed by other fundamental quantities, they are called as derived quantities. Example, area, volume and density. These physical quantities actually have two characteristics, one the numerical character and other the unit. Say for example, if you are having 3 kg of apple, number 3 is the numerical character and kg is the unit. Let's learn what is the unit. Unit, it is the standard quantity of a quantity or specific magnitude of a physical quantity. These units were adopted by law or convention. Earlier, we had different types of unit system like CGS system, centimeter gram second system, FPS system, foot pound second system, MKS system, meter kilogram second system, and etc. But later, at the end of the Second World War, after the General Conference on Weights and Measures in 1960, we adopted a new system of units called SI system. The abbreviation of SI system is International System of Units. This SI system, it is the modernized and improved form of already existing system of units. This SI system was accepted almost all over the world, and this SI system, it is having 7 fundamental units. They are, for length we are having meter, for mass we are having kilogram, for time we are having second, for temperature we are having Kelvin, for electric current we are having ampere, for luminous intensity we are having candela, and for amount of substance we are having mole. And the units which are used to measure the fundamental quantities, they are called as fundamental units. Like the same, the units which are used to measure the derived quantities, they are called as derived units. Now we are going to the do you know box. From the do you know box, first fact, it is fortnight. A fortnight is a 2-week time or 14 days of time. Moment. We usually ask people, wait a moment. So now what is a moment? Moment is 1 by 40th of an hour, is that 1.5 minute of time. And next one, it is atomus. Atomus is a time taken for eyelid shut or a twinkling of an eye. It is 1 by 6.25 second, is that 160 millisecond. Next one, it is donkey's power. We heard about the horse power. Now we are going to learn about the donkey's power. 1/3 of a horsepower, it is called as a donkey's power. Its value is 250 watt. And the next topic, it is fundamental units of SI system. In that, the first one, it is length. What is a length? Length is the distance between two known points, and its unit, SI unit, is meter. 1 meter, otherwise we can measure like the light travel in vacuum for 1 by 29 crores 97 lakhs 92,458 second. It is called as 1 meter. And while measuring the length, we have to measure longer distance and shorter distance. First, we will talk about the longer distance. For longer distance, we are having units like light year, astronomical unit, parasec, etc. What is a light year? Light year is a distance traveled by light in a vacuum for a year time. It is called as light year. Its value is 9.46 into 10 to the power of 15 meters. Next one, it is astronomical units. Astronomical unit is the distance between the center of the sun to the center of the earth. and its value is 1.496 into 10 to the power of 11 meters. Next one, it is parasec. If you take parasec, it is the largest unit. It is used to measure the astronomical bodies outside the solar system. 1 parasec, it is equal to 3.26 light year. From the do you know box, we come to know the closest star. It is Alpha Centauri, which is about 1.34 parasec distance from the sun. And now the smaller distance. So to measure the smaller distance, we are having plenty of units like Fermi, angstrom, nanometer, micron, millimeter, centimeter, etc. Here, the smallest distance is the distance between the atoms in a molecule. It is measured by angstrom. Now, the next do you know box, we are going to learn 3 facts. First one, the length of the blood vessel in human being, it is 96,000 kilometer. The second one, the height of the newborn baby giraffe is 6 feet, that is 1.8 meter. And the third one, it is talking about camelin's tongue. It is twice the length of its body. And next one, it is infobit. Apart from this SI system, our Tamil people also followed a conventional form of measurement system. So from that, 1 feet it is equal to 30.4 centimeter, and 1 meter is 3.2 feet, and 1 inch is 2.54 centimeter, and 1 meter is approximately 40 seconds. These measurements are existing nowadays too, and it is used in carpentry works and plumbing works and etc. Next one, it is mass. What is the mass? Mass is the quantity of matter contained in a body. Its SI unit is kilogram. And a prototype of this 1 kg 1 kilogram cylinder, it is placed in the International Bureau of Weights and Measures at Sèvres, France. And this prototype is made up of platinum and iridium alloy. And now we are coming back to the unit, that is kg. In our smaller class, we already studied about what is a millimeter, what is a milligram, gram, kilogram, and etc. We will learn one more time now here. So 1 gram, what is 1 gram? 1 by 1000th part of a kilogram is a gram. 1 by 1000th part of a gram is milligram. And 100 kg it is equal to a quintal, and 1000 kg it is equal to 1 metric ton. And the next one is atomic mass unit. This atomic mass unit AMU is used to measure the mass of proton, neutron and electron in a molecule. And 1 AMU it is equal to 1 by 12th mass of a carbon 12 atom. And next one is another do you know box. It is talking about TMC. 1 TMC it is equal to 2.83 into 10 to the power of 10 liters. That is approximately 30 crores of liter. And next topic, it is time. We usually use time to talk about a duration of an event or an interval between events. So the SI unit of time, it is second. What is 1 second is? Here 1 second is the time taken by light to travel a distance of 29 crores 97 lakhs 92,458 meters of distance in vacuum. Otherwise, we can define as 1 by 86th part or 400th part of a mean solar day. The larger units of times are day, week, month, year, millennium, etc. 1 millennium it is equal to 3.16 into 10 to the power of 9 seconds. And the next fact, this is talking about time, how we are practicing time in our village area. apart from SI system. They call 1 hour it is equal to 2.5 naligai, and 1 day it is equal to 60 naligai. They are separating the one complete day into a day and night. The day starts from 6 a.m. and it ends by 6 p.m. And the night starts with 6 p.m. and ends with 6 a.m. So both day and night they are having 12 hours each. So this 12 into 2.5 it gives us 30. So 30 naligai for a day and 30 naligai for a night. Totally for one single day we are having 60 naligai of time. Next one, temperature. We usually use temperature to measure the hotness or coolness of a body. The SI unit of temperature it is Kelvin. 1 Kelvin it is equal to 1 by 273.16, and the temperature at which the saturated water vapor, pure water and melting ice it is in equilibrium, then it is called as 0 Kelvin or absolute zero. The other units to measure temperatures are Celsius, Fahrenheit, etc. And in table 5 they actually gave us how to convert this Fahrenheit to Celsius Kelvin and Celsius to Fahrenheit Kelvin and Kelvin to Fahrenheit Celsius. So I'll explain, try to understand. Okay, first we begin with Fahrenheit. So we are going to convert Fahrenheit into Celsius. For that we have to minus 32 from the Fahrenheit value, and then we have to multiply it with 5 by 9. We will get the Celsius. For Kelvin conversion, we have to again minus 32 from the Fahrenheit value, and then we have to multiply it with 5 by 9, and then we have to add 273 along with it. We will get the Kelvin value. Now conversion of Celsius to Fahrenheit and Kelvin. First Fahrenheit. Okay. For that we have to multiply the Celsius value into 9 by 5, and then we have to add 32. Then we will get the conversion in Fahrenheit. And for Celsius to Kelvin conversion, we have to just add 273 along with the Celsius value. We will get the Kelvin value. And next one, last one, it is Kelvin to Fahrenheit and Celsius conversion. We will begin with the Fahrenheit. So for the Fahrenheit conversion, we have to minus 273 from the Kelvin value, and then we have to multiply it with 9 by 5, and then we have to add it with 32. We will get the conversion in Fahrenheit. If we want to convert it into Celsius, then we have to just minus 273 from the Kelvin value. We will obtain the Celsius value. Next one, unit prefix. This unit prefix is helping us to arrange the quantities. Like we are having a table 6 which is explaining the order. Peta is 10 to the power of 15, tera is 10 to the power of 12, giga is 10 to the power of 9, mega is 10 to the power of 6, kilo is 10 to the power of 3. Like that it will go down. And the next topic, it is rules and conversion for writing SI units and their symbols. So here we are having 10 points. I'll explain one by one. The first point, the units named after the scientist. That means units which were derived by a scientist. Okay, these units will not be written with the initial capital letters. Usually when we are writing a name, we usually used to write the first letter in capital letter, but here when we are writing the units after the scientist's name, we should not use the initial capital letters. And the second point, but the symbols for the units derived after the scientist, here we can use the initial capital letter as a symbol. For example, if you are taking Newton, the first letter N we can write in capital N as a symbol for Newton. And the third point, we are having some small letters of symbols also. These symbols were derived, not derived by a proper noun. And example, we are having meter, kilogram, etc. The fourth point, we should not use any full stop or punctuation at the end of the symbols. Fifth point, we should, these units should not be in plural form, like kgs, like that, meters, like that. And sixth point, it's talking about temperature. While you are expressing the temperature in Kelvin, you should not use the degree sign. Of course, if you are going to use Celsius or Fahrenheit to express, then you can use the degree sign. Seventh point, it is talking about the solidus. Solidus is just the slash or division symbol. In a unit, you can use only once this solidus symbol, not more than one time. Eighth point, numbers and units should be written in proper spacing. And ninth point, only accepted symbols we have to write. Like for an example, every time when we are writing, we may write like for second SEC, but this is wrong. We have to write completely a second. 10th one, when we are expressing a value of a physical quantity, we have to write it in full scientific form. Like we are having an example here, density of a mercury. We have to write this density as 1.36 into 10 to the power of 4 kilogram per meter cube, but not like 13,600 kilogram per meter cube. Thank you, class. The first session is over. I'll put you the next session tomorrow. Thank you.